Hello, in a previous video I made this remote control door closer and opener, and I was getting really annoyed with its poor range. So in this video I'm going to swap out the transmitter and receiver and see if we can improve this, once again without using any microcontrollers. After searching around I found these chips, the PT2262 and PT2272 encoder and decoders. They weren't much like the HT12D and E chips we used before, but they have one big advantage. Like the HT12D and E chips, they also use a resistor to set the internal frequency. That frequency isn't affected by the input voltage anywhere near as much. Looking on eBay, I found these receivers all set up and working at 433 MHz, just like the other chips I used before, and they can be set with a unique address to keep them all separate. It's almost a drop-in replacement. Aside from the chips, these boards have amplification circuitry on them. They should also be much more sensitive, meaning you should in theory be able to control them from much further away. However, finding a suitable transmitter module for these proved a little bit more difficult, especially in the 433 MHz range. You can, however, buy remotes that can be programmed from a known signal. So if I get the encoder chip and set it up with one of the transmitter boards I had before, I should be able to program the remote with that signal too. This means we may not need that ridiculously large remote control that I built before. Well, that's the theory at least, so let's get it set up on a breadboard and test it. Firstly, I'm wiring up the receivers. I'm wiring both up so I can see what the difference is between them. I've connected LEDs to the valid transmission pin so we can keep an eye on what's going on. Now the transmitter. I'm going to use one of the 433 MHz transmitters from before, but connect it to this encoder. The only other thing I need is the resistor required to match the decoder, and according to the datasheet, these are the recommended resistor values. Now taking a look at the two receiver boards, they both seem to be using an 820k resistor for the oscillator. This means we need a 4.7 megaohm resistor on the transmitter. The only difference here is we can't leave the inputs floating, they must be either connected to ground or the supply rail, but for this experiment that's irrelevant. With both wired up, let's give that a test! Well, it all seems to be working. I'm going to walk away with the transmitter and see what happens. The right hand one seems to be a little less reliable. Almost instantly it starts to flicker. But the one on the left, well, I ran out of space at 9 meters, and that's a lot more than before. Well, it works on the breadboard, but we need a more permanent solution. So to make that easier to build, here's the new circuit diagram for the receiver. You'll notice it's much simpler than the previous version, owing to some of the logic being on the receiver PCB. As before, I'm using the valid transmission pin to control a MOSFET, which will allow the motor driver chip to be powered. There's not much else to say about this, so let's replace the old version and build this up. And giving that a quick test. It works! So that's the receiver done, onto the transmitter, and the circuit will now look like this. Again, it's almost identical to the circuit we had before, just with a different encoder chip. So, let's retrofit this design into the controller from before. And, as you can see, there's not a huge amount we need to do. We have to change the oscillator resistors, attach pull-up resistors, and to make it easy, I'm connecting D0 to D3 and D1 to D2. As for some reason, on these chips they're in the opposite order. Before powering up, I discovered I needed to leave pins 10 and 11 disconnected. That's for data 2 and data 3. For some reason, if they're connected directly to data 0 and data 1, the chip gets very hot. It works! Now, this transmitter is massive, so I've purchased this keyring off eBay, which apparently you can program with most codes by letting it learn. So let's have a go at that. To program this remote, you simply hold down one of the buttons very close to the transmitter until it starts flashing. And when I say close, I mean very close. And giving that a quick test, it works! And I guess the final moment of truth, fitting it back to the door and testing it. Well, testing this, I can get to the other side of the room and it still works, which is plenty enough range for me, and that's a massive improvement. Plus, I have now a much simpler controller to use it with. I know this end product, you could call it a little bit pointless, but part of that is just the fun of making it. I hope you liked this short video update, thanks for watching, and I'll see you in the next one.